Assalamualaikum, my dear students. Hope you are doing well by the grace of Almighty. Welcome to our NIEBS Home School. This is Marjia Islam, Assistant Teacher of Science, National Ideal English Version School, morning shift. Now I am going to take a physics class for class 9. Our lecture number 10 and our SW number 8, and our today's topic chapter 2 discussion. Now start our class. This is the discussion of part 2. Now go to your page 41. This is chapter 2, chapter name is motion, and this is our second part of discussion of chapter 2. Now go to your books page 41. Here is an example. Let us consider another example to understand the relation between velocity and speed more clearly. Tie a small piece of stone with a string and rotate it around head. Does the stone move with uniform velocity or with uniform speed, or with uniform speed and uniform velocity? Now answer. If you think for a while, you will be able to understand that the speed of the stone is not changing, but the velocity is changing at every instant, because at every instant the direction of motion of the stone is changing. Here is a stone and here is a string. This is moving around head. Now if the stone moves along a straight line, then the direction of its motion will not change. Since it is revolving, its direction of motion is changing continuously, so it is an example of uniform speed, not of uniform velocity. If it is uniform velocity, then it must be uniform speed, whereas for uniform speed is not granted that the velocity will be uniform. Now another question: if the stone is suddenly released, will it move with uniform velocity and with uniform speed? Answer: if the stone is released suddenly, it will move straight with uniform velocity and uniform speed. It will continue to move with uniform velocity and uniform speed if there is no air friction or gravitational force, etc. Now we go to the topic acceleration or deceleration or retardation. Now when an object moves with uniform velocity, I repeat, uniform velocity, it has no acceleration. I repeat, when an object moves with uniform velocity, the important term here, uniform velocity, it has no acceleration. If there is a change of velocity, then there is an acceleration. More clearly, we can say the rate of change of velocity with time is acceleration. Since velocity has both magnitude and direction, the change of velocity can occur in two ways. In our previous example, when you rode your bicycle along the car path, the change of velocity occurred at every turn, and you accelerated, although you travel the whole path with uniform speed. Acceleration took place due to change of direction only. If you tied a stone with a steering, as in the previous example, and rotate it over your head with uniform speed, then the rotating stone would change its direction of motion continuously. That is, the change of velocity will occur and acceleration will take place. If your motion is linear, then there is no scope of changing the direction. Then acceleration may occur only for the change of magnitude of the velocities or speed. Important line here: when the magnitude of the velocity increases, then we can say acceleration is taking place along the direction of the velocity. If the velocity decreases, then we can say negative acceleration. Here is the important line: if the velocity decreases, then we can say negative acceleration or deceleration is taking place. Now we can determine the acceleration of an object moving along a straight line. Here this is a question, here is a figure. This is y-axis is velocity and x-axis is time. Then in a figure, the change of velocity of an object with time shown. Identify where there is acceleration and where it is absent. Now we can see the figure. Here the figure name is change of velocity and object with time. This question answer is there is acceleration at, that means acceleration at point A, that means the starting point here and the final point is here, that means this A point is acceleration, and at B, here is a point B, this is the point of B, there is no acceleration, B point, because here is the uniform velocity. That's why this B point is the B point is no acceleration, but the A point is acceleration, because here the change of velocity, because here this position here the change of velocity, that's why there is acceleration. But in the B point, here is the B point started from here and final point is here. Here there is uniform velocity, that's why there is no acceleration. And the point C, the C point starting point is here and the final point is here. Here is the point of C, here is the change of velocity, that's why there is acceleration, that's why the C point is acceleration. And now here is the point of D, the D point, the D's first point is here and last point is here. Here is the decreasing of velocity. We can see here is the decreasing part of velocity, that's why there is negative acceleration, that's why there is negative acceleration. So my dear students, look at the picture. Here the A point is acceleration, A point there is acceleration, and B point there is no acceleration, and C point there is also acceleration, and D point there is negative acceleration. Now go to the point, go to the point of acceleration. Acceleration we can define by final velocity minus initial velocity by time. Acceleration we can define final velocity subtract initial velocity by time. If the initial velocity of an object is u and after time t the velocity becomes v, that means final velocity is v and initial velocity is u, then acceleration will be a equal to v minus u by t. The dimension of acceleration a equal to lt minus 2 and unit of acceleration equal to meter per second square. Unit of acceleration is meter per second square. Now we go to the equation. We go to the equation of motion. We go to the equation of motion. Here u is the initial velocity and a is the acceleration, t equal to elapsed time, and v equal to velocity after elapsed time, and s equal to distance covered in elapsed time. My dear students, here is the equation, fourth equation, v equal to u plus at and s equal to u plus v by 2 by t, and 3 number s equal to ut plus half at square, and 4 number v square equal to u square plus 2as. I derived this fourth equation elaborately here. So you girls, my dear students, I elaborately derived this fourth equation here. So first equation is v equal to u plus at. Here the u equal to initial velocity, a equal to acceleration, t equal to elapsed time, v equal to velocity after elapsed time, s equal to distance covered in elapsed time. So here is the figure. Here this point is initial point and this point is final point, and here the elapsed time is t, and here the presenting acceleration equal to a. Now we can write from the definition of acceleration equal to a equal to v minus u by t. This is the definition of acceleration. This is the definition of acceleration. So now we can multiply, cross multiplication, then we get v minus u equal to at, then the final line v equal to u plus at. This is the first equation of motion. This is the first equation of motion. Now go to the second equation of motion. Our second equation of motion is equal to u plus v by 2 into t. Here is the figure. Here u is the initial position and v is the final position, and the elapsed time is t. Here the distance from u to v equal to s and the acceleration equal to a. We know the formula s equal to vt, then we convert v equal to s by t. We know equal to s equal to vt, then we convert v equal to s by t, and we know this is v bar, that means u plus v by 2, u plus v by 2. Now this value form equation 1, this is the equation 1. We put the value of v bar equal to v bar into 1, then we get u plus v by 2 equal to s by 2. Now we calculate this. After calculating this, we get s equal to u plus v by 2 into t. This is the second equation of motion. Now go to the third one. Our third equation of motion equal to s equal to ut plus half at square. Now with the help of the part of 2, we get s equal to u plus v by 2 multiply t. Then here we put the value of v, which one we get from the equation of number 1, the equation of motion number 1, v equal to u plus at. We put here this value u plus, we put the value of v, our v's value is u plus at, then u plus at, then subtract this 2u, then we get ut plus at by 2 multiply t. Then after calculating this, we get s equal to ut plus half at square. This is the third equation of motion. Now if we consider initial velocity, that means u equal to 0, at first we consider initial velocity u equal to 0, then we get put this value of this equation, then we get s equal to 0 multiply t plus half at square, then s equal to half at square. Now this is half, and the value of acceleration a, this is the constant value. This is the constant value. That's why we can write s proportional to t square. That means distance proportional to time square. Now we go to the equation number 4. This is equation of motion. The 4 number equation of motion equal to v square equal to u square plus 2as. This is the figure. Here this point is initial velocity and this point is final velocity. Initial velocity to final velocity distance covered by s, and here the acceleration is a and the elapsed time is t. Now we know v equal to s by t, this is number 1 equation, and v equal to u plus v by 2 equal to number 2 equation. Now this is v equal to this value and this v equal to this value. So we can compare this 1 and 2 value, then we get this value and this value is equal. So we can write s by t equal to u plus v by 2. Now after calculating, we get s equal to u plus v by 2 multiply t. This is the number of equation 3. Now we know v equal to u plus at. From the equation of motion, the first equation of motion, we get this equation v equal to u plus at. After transform, we get the value of t equal to v minus u by a. V minus u by a. Now go to the equation number 3. Our equation 3 is this. Here now we put the value of t here. Now we put the value of t here, then we get s equal to u plus v by 2 multiply, putting the value of t, the t's value equal to v minus u by a. now multiply this value v minus u by a, then u plus v, and v minus u by 2a. That means here we using the formula a plus b, a minus b, that means a square minus b square. Now here v plus u, v minus u, that's why we use this formula v square minus u square. Now the cross multiplication, we get the result v square minus u square equal to 2as. Sutorang v square, so v square equal to u square plus 2as. Now if we consider the initial velocity u equal to 0, then we get the result from this equation v square equal to 2as. V square equal to 2as. After this, the final velocity equal to root over 2as. Here the constant value is root over 2a. So we finally get v proportional to root over s. That means velocity proportional to root over distance. My dear students, this equation related problem is given here. This 4 equation related problem is given here. Now I am describing this problem with solution. Now the question number 1, this is your books example, page number 46. You will see the velocity of a car is increased by 60 km per hour. I repeat, here this is the distance. That means we denoted by distance by s, 60 km per hour within 1 minute of starting from rest. What is its acceleration? Now here is the time t, 1 minute. We convert this time 1 minute to second. Now answer form. Now we will we will use the unit of time in second instead of minute or hour, and for distance meter will be used instead of mile or kilometer. The final velocity of the car v equal to, here this is the final velocity, v equal to 60, this is the unit kilometer per hour. Now we convert this kilometer, 60 kilometer, convert kilometer to meter, that's why we multiply 1000. Now 60 multiply 1000 meter by hour, this is the hour. We convert hour to second, that's why we multiply 60 into 60s. After calculating this, we get the result 16.67 meter per second. My dear students, I repeat, here is the 60 km per hour. This is the final velocity, that means v, 60 km per hour. That means we convert 60 km to meter, that's why we multiply 60 into 1000 meter, and hour convert to second, that's why we multiply 60 into 60s. We know 1 minute equal to 60 second and 60 minute equal to 1 hour. So the problem is like this: a car attains a velocity of 16.67 meter per second. This is this value 16.67 meter per second in 60 seconds starting from rest. What is its acceleration? Here this is the time, 1 minute. That's why here we can write 60 seconds starting from rest. What is its acceleration? Now we know the formula. We know the formula actually. V equal to u plus at. This value is 0 because from the rest position. That's why we write u equal to 0. That means we can write v equal to 80. Now our expected acceleration a equal to, we can write from here, a equal to v by t. Now put the value of v, that means final velocity 16.67 meter per second by the time 60 seconds. After calculating this, we get 0.278 meter per second square. Now go to the question number Next question, a car is moving with a velocity of 60 mile per hour. Suddenly its engine stops. It takes 5 minutes to come at rest. What is the acceleration of the car? Now answer, when there is acceleration, velocity increases, whereas velocity decreases of when there is negative acceleration or deceleration. Now again we will use S for time and M for distance. We use S for time, S means second, and M for distance, that means meter. Now here our given value equal to 1 mile. Now we convert mile to, at first convert mile to kilometer, then kilometer to meter. 1 mile equal to 1.6 kilometer. We know this value is known value, 1 mile equal to 1.6 kilometer. Now we convert kilometer to meter, that means we multiply 1000, then we get 1600 meter. Now initial velocity of car u equal to 60 miles per hour. 60 miles per hour. Now we convert 60 miles. That means at first miles convert to kilometer, then kilometer converts to meter. That's why 60 multiply 1.6 multiply 1000 meter. That means miles to kilometer, kilometer to meter. And hour, it converts hour to second, that means 60 into 60 second. That means 60 into 60 second, we know 60 second equal to 1 minute and 60 minute equal to 1 hour. That's why here multiply 60 into 60 second. After calculating this, we get the result 26.8 meter per second. Now final velocity of car v equal to 0. We consider final velocity of car v equal to 0, then acceleration, we know the definition from acceleration, a equal to v minus u by t. Then put the value of v and u and t, then we get the result minus 0.089 meter per second square. Here we get the negative result, that's why the acceleration of the car minus 0.089 meter per second square, or deceleration or negative acceleration. Our negative acceleration result, when we said deceleration or negative acceleration, then we avoid the minus sign, then we can write 0.089 meter per second square. Now go to the next question. The velocity of a bullet is 1.5 kilometer per second. It has penetrated 10 centimeter of a wall. What is the deceleration of the bullet? Now answer, the only way to solve this problem is to use the formula. This is the formula of equation of motion. Equation of motion's 4 number formula. We know b square equal to u square minus 2as. Now here the given value u equal to 1.5 kilometer per second. Now we convert kilometer to meter, that's why we multiply 1000 with 1.5. Now here the final velocity is 0. Now we put this value from this equation, then we get the a, that means acceleration, equal to 11250,000 meter per second square. This is our deceleration or negative acceleration. Okay, my dear students, I have finished today's topic. Your homework is 2 math. This is your homework math number 1. This is your homework math number 1 and this is your homework math number 2. Our homework topic, our homework number is 8 and our homework topic page number 46. Page number 46. This math is your homework and 47 page, this math is your another homework. 2 math. This math and this math. This 2 math is your homework. My dear students, I hope you have understood today's topic. See you again in the next class. Till then, Allah Hafiz. Assalamu alaikum.